So we can classify lipids as either storage lipids or membrane lipids. One example or one common example of storage lipids is triacylglycerols. They're also known as triglycerides, fats, or neutral fats, right? So they're really fatty acid esters of glycerol, where you have a glycerol molecule, and that glycerol molecule forms an ester linkage to fatty acids. Now, the identity of the fatty acids is variable, right? Shown in this diagram is 3 different fatty acids. But if it contains the same kind of fatty acids at all 3 positions, then it's typically known as simple triglycerides or triglycerols. So for instance, if you have a triglyceride that is composed only of palmitic acid, which is a 16 carbon fully saturated fatty acid, then we'd call it a tripalmitin, right? Or if it's composed of a number of different groups or a number of different fatty acids, then its name really specifies the position of the different fatty acids, and those are known as mixed triglycerides. So the example that we see on this slide is an example of a mixed triglycerides, because the identity of 2 or 3 of the fatty acids is different. Right, and what we have is an ester linkage, and again, if you notice that, that's an example of an ester linkage. All right, so you have 3 different fatty acids, each has an ester linkage with a single glycerol molecules. So triglycerols can function as energy storage, and an example of that is invertebrates or animals, which are specialized. There are specialized cells known as adipocytes, which are pictured right in here. They are also known as fat cells, and their role is to basically synthesize and store triglycerides. And there is a certain enzyme present within adipocytes known as lipase that basically catalyzes the hydrolysis of the different triglycerides, releasing fatty acids that then can be exported to different sites where they are needed or required as fuel, right? In human, those adipocytes basically are composed of fat tissue, right? Or human fat tissue is basically an adipocytes, also known as fat globules. Okay, they can also provide insulation for warm-blooded animals such as seals and penguins. All right, so we could use then triglycerols as energy storage or fats, but we could also use carbohydrates. And if you think about either one, triglycerols, and if we go back to the structure of the triglycerols are more reduced, so their oxidation could lead to more energy, right? As opposed to carbohydrates, which are more oxidized. If you also think about triglycerides, they're more hydrophobic, so they're unhydrated, so they don't carry the weight of water, as opposed to carbohydrates that we typically said they're very hydrated because of their hydrogen bonds with water. Right now, one of the positive things about carbohydrates that they could be used as a quick source of metabolic energy, right? And they are soluble in water. But in the long run, people that might be slightly obese, having 15 to 20 grams of fat or excess amount of triglycerides deposited in their adipocytes, they could actually meet their energy needs for a few months. Whereas in comparison, meeting the energy needs from the supply of glycogen would last someone just about 1 day. Right? So that's just a brief comparison between carbohydrates and triglycerides in terms of energy storage.